gets us ready for the last section where we do a whole bunch of word problems involving rational expressions. And one type of word problem here deals with distance, speed, and time. If you took a science class, you might have seen the formula that relates distance, speed, and time. Does anyone remember it? Uh-oh. We got one? Distance equals speed over time? Close. Now, if you have trouble remembering it, speed equals distance over time. There's the formula, speed equals distance over time. So close. The best way to remember this formula is, have you ever seen a speed limit while driving? Absolutely. Can you give me an example of a speed limit you've seen posted while driving? 50 kilometers per hour. The speed, that's your S. Sometimes in physics they use V for velocity. That's fine. Is kilometers per hour. Kilometers is distance. Per is the divide. Hours is time. So if you've seen a speed limit, you know the formula. It's a really easy way to know the formula. Now, if you have this formula, you can rearrange it to get any letter by itself. So if I want to get the D by itself, I would have to multiply both sides by T. I don't know, maybe you remember this formula. I don't know, STD sounds like not a good formula. Maybe we shouldn't write it that way. We could also get the T by itself by dividing both sides by the F. So we have all three of these formulas. Now I've kind of given you two easy ways to remember them. Right? You've got the STD formula for science, and you've got just thinking about kilometers per hour. Speed is distance over time. Okay. Now we read this question. On a canoe trip, Patan paddled upstream a distance of 10 kilometers. On the return trip downstream, the average speed of the canoe was 5 kilometers per hour greater than its speed upstream. Write, then simplify an expression for Patan's total paddling time in terms of the average speed upstream. Okay? If you read this question, probably your first thing is like, I'm a little overwhelmed. I don't know where I would start. So for these distance, speed, and time questions, they will be easier if we sort of make a chart to organize our data. We have two things happening, so I'm going to make a chart here. We have two things. We are going upstream, and we're going downstream. And in my distance, speed, time formula, I'm just going to write down distance, speed, and time, and see if I know any of this information. Like, for example, do we know the distance traveled upstream? Yes. So we can put 10. You could add the units here if you want. We know that that's 10 kilometers. Do we know the distance downstream? Yes. It's exactly the same. It's a return trip. It's going to be exactly the same distance downstream. Do we know the speed? Did they tell us how fast he's going upstream? No. In fact, in the question, they said the following, which is a little bit of a hint. In terms of the average speed upstream, they're kind of telling you, make this your variable. Some people use S because it's speed. Some people say, I just like using X. So if you want something in terms of the average speed upstream, that's going to be your X. Now, if we don't know another thing, for example, we don't know the downstream speed either, but everything has to be in terms of the average speed upstream. So if this was X, how fast is this?
X plus 5.
X plus 5. Because it tells us that it's 5 kilometers per hour faster downstream. And this is where the formulas, once we get to time, this is where the formulas come in. I don't know the time either, but I know from my formulas, I would use this one. Time is always distance divided by speed. Do I know the distance? Yes. Do I know the speed? Well, no, but I have a variable there, so I can write my time as distance divided by speed, and the time here will be distance divided by speed. And the question was asking us to find the total time. Well, the total time would be one time plus the other time. So it's going to be 10 over x plus the 10 over the x plus 5. And it also says once you've done that, simplify it to write it as a single fraction. So how do I add fractions? I need a common denominator. You see that this one, it's grouped together, would need the x plus 5 and an x plus 5. And this one will need an x and an x. It gives me a common denominator of x times x plus 5 there, and a common denominator of x times x plus 5 here. If I distribute this one, I get 10x plus 50. If I just multiply this one out, I get 10x again. Now I have a common denominator. I can add my like terms. 20x plus 50. You can factor a 10 out of the top just to see if anything cancels out, but it doesn't. And so this is a simplified expression for the total time. And you'll notice that instead of just saying for the non-permissible values, instead of just saying x can't equal -5 and x can't equal 0, this question has the following. X has to be bigger than 0, because x is a speed. You cannot be traveling at negative speeds. You'll never get there. Also 0. It's very hard to get somewhere if you're traveling at 0 kilometers per hour. Right? Can you imagine? Do this to your kids one day. We're going on a long trip, and sit in a parked car for as long as possible until they say something. Right? They probably won't say, like, you need to work on your kids if they say, "Are we there yet?" Like, we haven't gone anywhere. Your speed is 0. Yes?
The textbook doesn't simplify the...
No, the textbook left it as 20x plus 50. I factored it to see if something else would cancel. Sometimes when nothing else cancels, you could leave it either way. But the factored form is probably preferred. All right, so circle question number 11. What's going to happen in the next section, in our last section for this unit, they'll actually give you the time. They say it took them 2 hours total there and back. How fast were they going? And as soon as we get a 2 for total time, now we can solve the equation. But for now, we just wrote an expression for the total time. If I made it equal to 2, we'll look at solving. How do we solve this?